Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to explain your random forest model. So in the last video I showed you how to build a random forest classifier model, and here we instantiated our random forest classifier model as RFC. So RFC is the variable that is holding our random forest classifier model. So if you see me using RFC, that is where it comes from. And so in the last video I showed you how to build a random forest classifier model. Go ahead and watch that video if you need to. And in this video I'm going to be focused on showing you how to explain a random forest classifier model. So right here, if I go ahead and do RFC dot future importances, you will get these numbers. But what does these numbers actually mean? First of all, let's go here, and this is a documentation for random forest classifier model, and as you can see right here, it has a future importances attribute. So future importances is one of the attributes you have access to, and basically most times in scikit-learn library, attributes are the things you have access to after you instantiate the model and run the model through your dataset. You'll be able to have access to all this information if you need it. But in this video we'll focus on using the future importances. So these are the future importances from the random forest classifier model. And what does future importances actually mean? Let's go back here and read this thing that I wrote. What is future importance? Future importance is, on average, how is each future decreasing the tree model's impurity. When a tree splits a node, it uses the impurity, which is the information gain, and this is the equivalent of variance in a regression model, to decide which future to use to split the node. The future that produces the lowest impurity will be used to do the split. This means that we can kind of use our future importances to gauge how important each future is. This might allow us to achieve the same high accuracy using less features by just selecting the most important features from our data frame. So in summary, future importance is how much each feature contributes to decreasing the weighted impurity of the model. And this becomes very important because it will show you which features in your data frame has the most impact on your model, and if you know which features has the most impact on your model, you can just use those features to run your model. You don't have to use all the features and use up a lot of resources. Just use the most important features, right? So that's basically what future importance means in a decision tree. And basically in a random forest model, the future importance is the average importance from the many different trees the forest model is using. Okay, so basically, a random forest model is a combination of many different decision tree models. Okay, so in a decision tree, which is just a single tree, the future importance is the measurement of the weighted impurity, decreasing weighted impurity. But in a random forest model, the future importance is the average importance. So it will take all of them, all the future importances, and take the average of the many trees that makes up the random forest model. So just keep that in mind. I just wanted to give you a quick explanation of what future importance means in a classification model. And each one of these numbers corresponds to a column in our data frame. So if I go ahead and pull up our string.head, you see these are the features that make up our data frame. These are the features that we're using to predict the wine quality. So this data frame is about predicting wine quality. So these are the exact same thing, but these are just the columns. So what I'm trying to say is that each one of these future importance corresponds to a column right here. Okay. Now just looking at these future importances and looking at this list of columns, it's kind of difficult to make the correlation of which future importance goes with which column. And also it's difficult to visualize which features are most important just looking at the raw numbers and the column. So in order to make it easier to quickly look at this data and visualize the most important features, I am going to combine this column with their corresponding feature importances. Alright, so we have importance and we have column. So now we are going to create a pandas series between our feature importances and our column. So earlier in this notebook, I imported pandas as PD. So this PD right here is pandas. If you see PD, it stands for pandas. And the first thing you provide is the data. And the second thing you provide is the columns or the index in this case. So if we go ahead and do RFC, run this, you can see right here, the future importances has now been aligned with their corresponding columns. All right, this makes it easier to associate the necessary future importance with their corresponding column. But still, this is not enough, okay? This is not a quick, easy way to visualize which features are most important. So what I'm gonna do right now is kind of create a graph of this. So you can just look at it and be like, oh yeah, this belongs with this. So this is a magic command. And it's matplotlib basically. And basically what I'm gonna do right now is do rfc cof dot sort values. This is one way to graph this. There's many different ways to graph it, but this is just one quick method for graphing it. So what we have right here is a graph of our feature importances, and I'm just gonna add this semicolon. So adding this semicolon at the end removes this right here. Alright, so basically I just took this feature importance and their corresponding column and just plotted it like this, and I don't like, let me make the color red. Okay, that looks nicer. So I was able to do this dot plot because of matplotlib, and then bar means I want a bar graph, edge means I want it to be horizontal. Okay, so if you don't have matplotlib in your environment, you won't be able to do this. So make sure you have matplotlib in your Anaconda environment or ppenv environment or whatever environment you're using. Make sure you have matplotlib. If not, you won't be able to do this. But as you can see right here, it gives us a quick visual representation of which features is the most important in the random forest model. So this is pretty cool, and this is just one way to explain your model or to like kind of make sense of your model's performance, right? And another way is using a confusion matrix or using precision recall and F1 score. So in a different video, I go into detail of how to calculate precision recall, F1 score, and what they mean. So go ahead and make sure you watch that video. But in this video, I'll just give you a quick overview of how you could use it to explain your random forest model. And we just do from sklearn.metrics import classification report. All right, and then let's get and run this, and then we can do print classification reports, and here you pass in your true value and then your test value. So your true value and your predicted value. So when I did my random forest classification, I stored my predictions in this variable. So this is my predicted variable and this is my true variable. If I run this, it will give me the classification reports for this, and it will give me the precision, the recall, and F1 score, and it will also give me the accuracy right here in this report, and it gives you the precision, recall, and F1 score for each category. All right, So this is pretty cool. This is another way to kind of like explore the performance of your model. And of course, go and watch the video on precision recall and F1 score to learn more about this. So another method is using a confusion matrix. And again, in a different video, I go into detail about confusion matrix. But in this video, I'll just give you a quick overview of what a confusion matrix will look like and how you could use it to explain your model. So this right here is the confusion matrix for the random forest classification model. And from this confusion matrix, you can calculate the precision, the recall, and the F1 score. So you can basically get this exact same information just from the confusion matrix. All right, so confusion matrix is kind of showing you the actual value and the predicted. Okay, so basically for this example, like 436 times, the value was actually 6 and it was predicted to be 6. All right, 106 times, the value was actually 7 and it was predicted to be 7. And then here in this situation, it's showing that 10 times the value was actually 8, but it was predicted to be 6. So that's kind of how to interpret this confusion matrix. But these are just a couple of techniques for explaining your random forest classification model. And of course, in a different video, I go into detail about confusion matrix. So confusion matrix, you can get a classification report, you can visualize it like this. And this is just a few. You can also do something called Shapley plot. You can do something called partial dependence plot. There's different techniques for explaining your models, and you can find all those videos here on my channel. And to get access to this notebook that I use in today's video, just go to machinelearningeducation.com. This is my website where I put all my notebooks and resources. So if you go here and click on this, you'll be able to get to this page, and from here you can get access to my notebooks. So I create a lot of YouTube videos, a lot of blog posts, a lot of content, and I just find it easier and more straightforward to take all my notebooks, all my videos, and all my blog posts and put it under one platform. And when you come here, you get access to this notebook, and you can also find me online at evidencen.com. This is my primary website where I have my data science blog posts, and as time goes by, I'm going to create more and more data science blog posts. And if you are here on this website, you can also go to free data science resources and be able to get access to this page. That's it for this video. If you like it, please give it a thumbs up and subscribe to the channel. If you made it this far in this video but you didn't like it, please give it a double thumbs down and still subscribe to the channel. Thank you for watching, and I'll talk to you on the next one. Bye.